So why isn't 1, 3, 4 an odd permutation? There's an odd number of cycles here. There's an odd length for the cycle, but it's not an even permutation. How do we write 1, 3, 4 as a product of transpositions? Anyone remember?
1, 4.
Yeah. 1, 3, 1, 4. Well, I might modify that a little bit today. But yeah, 1, 3, 1, 4 is the same thing as 1, 3, 4. Modulo a comment about order that I need to make today. But yeah, so that is a product of those two transpositions, and therefore, what kind of permutation is 1, 3, 4? Even. Right, so of this list, the only odd permutation is that single transposition, 2, 4. Yeah. So let me take this opportunity to make a quick comment about order here, because this is something that I will confess that I screw up regularly until I think a little bit extra about it. So we convinced ourselves in the last class that the order in which we compose permutations matters, right? Generally, permutations don't commute with one another. So if I write 1, 3, 1, 4, what am I really trying to do in that permutation? Let's say I have my 4-letter word, post, right? If I write 1, 3, and then 1, 4 in this order, then what am I doing to post, first of all? P and the S. So here's 1, 3. So why, Colleen, why are you disagreeing with... Contravariant, what a great word. Contravariant was not used in that song that you just saw, but contravariant is used in a different place on the album. See if you can find it. So here's the thing. Because order matters, we all have to agree on what a composition of two permutations means that we're doing. And there are two choices we can make. We can either read this in the way that we read the dihedral group before, right? When we wrote down TR squared, we thought of it as first do T and then do R squared. Or we could read it the other way. And the motivation for reading it the other way is that that's how function composition works, right? If I think of permutations as being functions, which they are, they're bijective functions from a set to itself, then when 1, 3, 1, 4 acts on a set of elements like the word post, that post is like the x that I'm feeding in to my 1, 4 function. And that 1, 4 is then happening first, and then 1, 3 is happening to the result. Right? So when you write down two permutations side by side, mathematicians have agreed that because permutations represent functions, that we will read the composition of these permutations not from left to right, but from right to left. So 1, 3, 1, 4, what's the first thing that happens?
False.
Yeah. First, do the 1, 4 transposition, and then the O and the S are fixed, and then do the 1, 3. Yeah. SOTP. That's what this ends up being. Right, so 1, 4, and then 1, 3. And by the way, is that the same as 1, 3, 4? Yeah, it's not. So here, 1 goes to 4, which goes to 3, which goes to 1. So that composition, 1, 4, 1, 3, 1, 4, written in this way, is actually what 3 cycle? 1 goes to 4, which goes to 3, which goes to 1. Yeah, 1, 4, 3.
Oh, so it should just be written 1, 4, 1, 3?
Yeah, if we were to write that as a product of transpositions, using the contravariant ordering that we're going to make our convention, we write it as 1, 4, 1, 3. It's still an even permutation, whichever way you slice that cake, right? But I want to be crystal clear about that, because what I actually ended up doing with the last set of videos is I posted like 9 videos. And in the video in which I was explaining how to compose permutations, I actually got this order left to right instead of right to left. Because again, I make this mistake a lot. So I ended up going in and replacing that video in the playlist with a video with the corrected ordering in it. So when you look back at the list, you should see you should see it listed in the right way. And in the videos that have left-to-right ordering, I put a big word caution in the description of the video, just in case. Because I think there are still some mathematicians who do prefer the covariant ordering for permutations. There's just not that many, and the authors of our textbooks are not among them. So I'm asking you, what is the order of this permutation inside of a group? I didn't specify which group this lived in, but let's assume for the moment that it lives in the group S10, so a symmetric group on 10 symbols. What is the order of the symmetric group on 10 symbols? Remember at the end of our last class, we talked about the order of the group of permutations? How many permutations of 10 symbols are there? How many ways to rearrange? 10 factorial. Anyone know what that is off the top of their head?
A lot.
A lot. I agree. It's definitely a lot. That's a correct answer.
Couple 10,000.
Bigger. Yeah. So a ton, right? 3.6 million. Okay, and so Brian's saying that the order of an element in this group has to be a divisor of the order of the group, which is a statement I agree with. We haven't proved it in general, but we saw it was true for cyclic groups, right? And so if S10 were a cyclic group, we would know for sure that there's an element of order 10, because 10 is one of the divisors in 10 factorial. Okay. Somebody else defend their answer. Okay.
I said 24 because it's multiplication for
Okay.
elements times 6 elements, we could use 24.
Okay. So the first of these two things in the product here, 1, 6, 4, 2, that's a 4 cycle. So what's the order of this element?
4.
Yeah, order is 4. So the nice thing about cycles is that they tell you what their order are. Orders are grammar. And what's the order of this one? 6. So I have an element of order 4, and I have an element of order 6. And so a reasonable conjecture is that the order of their product will be 4 times 6. My rebuttal is this cartoon. So what in the world is happening in this cartoon? Why is this meme a rebuttal to the argument that the order is 24? Alexis?